Rationals. There are two types. One type we can solve by cross multiplying, but cross multiplication doesn't always work. Okay, so I'm going to show you the cross multiplying one because it's easier, but it doesn't always work. The other one always does. So there's one type. We can do cross multiplication. Cross multiplication can only happen when it's a cross and equal sign. So we have to have a full fraction like an A and a B, and it equals another full fraction, a C and a D. We can't have like a plus 6 at the back or 6 minus A over B. It has to be full fraction equals full fraction, and then we can cross multiply. So we have to have an equal sign in the middle, and then we can multiply across an equal sign. So I'll give you an example. This is the butterfly. But it only works sometimes. So, more rarely than it does work. So solve. Three over x plus 3 equals 9 over 4x plus 7. So we have full fraction equals full fraction. We agree? The moment we cross multiply, the denominator goes away. And what do we always have to do before we get rid of our denominator? State MPVs. So MPVs, this is actually the lesson where MPVs are the most important. The reason why is we're going to get an answer. We're going to get like x equals 2 or x equals 5 or x equals negative 7. And the NPVs are the values that it can't be. So sometimes you get an answer that's actually a non-permissible value. And if you don't state the non-permissible values, you're not going to say that that root doesn't work. You're going to pick it and you're going to be wrong. Okay? So our x values that don't exist are x plus 3 cannot equal 0. And 4x plus 7 cannot equal 0. So x cannot equal negative 3. And x cannot equal negative 7 over 4. So down a ways, I'm going to go x cannot equal negative 3 and negative 7 over 4. And I'm going to put a box because I want to have it down here so that I remind myself to be like, hey, is my answer one of these? If it is, then the answer doesn't work. Okay. So we have a fraction equals a fraction. The only time we can cross multiply is if we have a fraction and it equals a fraction. We agree? If there was a multiplication symbol in between them, can we cross? No. If there's a multiplication symbol in between them, we can cancel stuff off the top and the bottom, but then we multiply straight across the top, straight across the bottom. We agree? With an equal sign in between, we can cross multiply. So we can go 9 times x plus 3 equals 3 times 4x plus 7. And then I can just solve, do math. So distribute my 9 through. 9x plus 27 equals, distribute my 3 through, 12x plus 21. Now I have an x on either side. You just need to pick one and move it. Don't spend 20 years trying to figure out which one's better or sit there and be like, I don't know what to do next. When there's two x's, one on each side, just pick one of them and move it to the other side. It doesn't matter which one. I'm going to move the 9. I'm going to subtract it over. If you use the 12, it'd be absolutely fine. So I'm going to get 27 equals 3x plus 21. Then what am I going to do? Minus the 21. So I get 6 equals 3x. Then what am I going to do? X equals 2. And then I box it and say I'm done. You check your non-permissible values. Is 2 one of the non-permissible values? No. Then we're good. Remember, you can actually check your answers too. You type it back into the original and see if you get left side equals right side. So it's called verification or a check. So I'm going to put 2 in for all the x's. So I'm going to get 3 over 2 plus 3 equals 9 over 4 times 2 plus 7. So I get 3 over 5. And when I check, nothing moves from left to right. I just move way down, down. 9 over 15. And this is 3 over 5 equals 3 over 5. They match. Sound good? So I walk away from this question being like, boom, got this, right? So I'm going to give you one where you can cross multiply. But remember, what did I tell you? Cross multiplying only works sometimes. And it has to be a fraction equals a fraction. If it's not in that, it won't work. Okay? So we don't want to always bank on this method because the chance of it being this working is way slimmer than the other method. Okay? So I'm going to get you to practice one of these where you can do this. And then we're going to do the other way. What if you don't have a fraction equaling a fraction? Let's see if you get stuck on this one or if you can work your way through it. A hint, you're going to have a quadratic, so you're going to have to use the quadratic formula. If you're like, what is the quadratic formula? It is on your formula sheet. You have to use it when it's on the very bottom of yours. It's also on the very top of the 30-1. So cross multiply, and when you get an x squared, you have to move everything to one side. I want to see who can work through it. Let's see. Oh, I didn't freeze it. Okay, so this one you don't need the quadratic formula for. Oops. It canceled so nicely. Okay, so we're going to go 4x minus 2 bracket 3x plus 5 equals, and this only worked because the x squareds both were the same number, right? Other than that, wouldn't have worked. So we get 4x times 3x, which is 12x squared, minus 6x plus 20x minus 10 equals 12x squared minus 2x plus 18x minus 3. If you subtract the 12x squared, what should I have done first? MPV. X cannot equal negative 3/2 or negative 5/3. Okay. Then I can collect like terms. 6x plus 20x is 14x minus 10 equals negative 2x plus 18x, which is 16x minus 3. Then pick a side. I'm going to move this over. Minus 14x. Negative 10 equals 2x minus 3. Add 3. Negative 7 equals 2x. 5 by 2. X equals negative 7 over 2. If you're not sure of yourself, what could you do? You can plug it right back into the original and see if left side equals right side, even if it's decimals, right? And we have to check the MPVs. Does it match the MPVs? No, so it's good. If it did, it'd be out. Okay, second step. What happens if it's not fraction equals fraction? Type 2. So what if it's not in that form? 3 over x plus 1 plus 1 over x minus 1 equals 2. What would 2 be over? 1. Okay. So just like the very first step of addition and subtraction, what did we do? We found, same thing here. We're going to find common denominators. So what's common to x plus 1, x minus 1, and 1? Trick question. Nothing. Each other. That's it, right? So you have to multiply everyone by what's missing. So I would have to multiply x plus 1, technically by x minus 1 and 1. Do I really have to multiply it by x minus 1, though? Or sorry, by 1? 1 doesn't do anything, so I can leave the 1 off, right? Then this one I would have to multiply by x plus 1. What about the last one? X plus 1 and x minus 1. It has none of them. What 3? So the bottoms of each of these are going to have what? Common denominators now. So we know we didn't mess up. Okay? What do we do when we have common denominators? We can just write everything over one of them, right? But I'm going to expand first. So last time when we did this with addition and subtraction, we'd expand. So I'm going to do that. I'm going to get 3x minus 3 over x plus 1, x minus 1. So all the same steps as yesterday. Plus, this is why we spent a long time on addition and subtraction, because you can't do that, solving's hard. Then we get 1 times something, well, it's just that something, x plus 1 over x plus 1, x minus 1 equals. Then I'm going to leave the 2 out, and I'm just going to FOIL these brackets. So I'm going to get x times x squared, minus x plus x minus 1. I'm just going to leave the 2 outside and distribute it after. X plus 1, x minus 1. Now what can I do on the left? Put them all over the same denominator. It's just addition, like we did before, right? It's just addition like we did yesterday. So we're going to have x plus 1, x minus 1 in the denominator because they have common denominators. And on the top I have 3x minus 3 plus x plus 1. And then this one I'm going to have 2x squared minus 2x plus 2x minus 2. Okay. The reason why we get common denominators is if I have this, a over x equals b over x, what could you tell me? They have common denominators, but what could you tell me about a and b? If a over x equals b over x, what must a and b be? The same. Because if this is x and this is x, the denominators, then the numerators have to equal. We agree? So once we get common denominators on both sides, we can just set the numerators equal to each other, which means our denominators go away. So before our denominators go away, what must we do? NPVs. So x cannot equal plus or minus 1. And then our denominators can go away. 3x minus 3 plus x plus 1 equals 2x squared minus 2x plus 2x minus 2. Because if the denominator equals the denominator, I can then just say, hey, get rid of those. The numerator must equal the other numerator in order for that to be a true statement. The moment I have 1x squared, I need to move everything to one side and use the quadratic formula. So I have an x squared here. Is it going to cancel off like that other one did? No. If it doesn't cancel off, I need to move everything to one side. So I'm going to subtract 3x. Oops. You can. Add 3, subtract x, subtract 1. Subtract 3x, add 3, subtract x, subtract 1. And then I get 0 equals, and now I collect like terms. 2x squared minus 3x minus 2x plus 2x minus x is minus 4x plus 3 minus 1 minus 2. They actually cancel off and I get a 0. Do I have 3 terms that I can use the quadratic formula for? Technically, if you really want to, you still can use the quadratic formula. I'll show you. Because we could write it like this: 2x squared minus 4x plus 0. And then this would be A, this would be B, this would be C. And we could plug it into the quadratic formula. 0 would just cancel off some stuff, right? Or what could we do instead of plugging in the quadratic formula because we don't have a number at the back? Take out a 2 and an x. Then I'm left with x minus 2. What would my two answers be then? X equals, treat it like an MPV, x equals 0 and 2. Box it. Why can I box it? What are my MPVs? Negative positive 1, and I said my solution is 0 or 2. So can I have 2 solutions? Yes. If I plugged in 0 by itself into the original, I get left side equals right side. If I plug 2 back into the original, I get left side equals right side. Solve. 5 over 3x minus 1 plus 3x over 3x plus 1 equals 1. What's common to those? Trick question. Nothing. So I'm going to end up multiplying the front one by 3x plus 1. This one by 3x minus 1. And this one by both. So we're going to go 15x plus 1, plus 5. That too. 3x minus 1, 3x plus 1. Sometimes it doesn't just don't happen. Okay, 9x squared minus 3x over 3x plus 1, 3x minus 1 equals 9x squared minus 3x plus 3x minus 1 over, and this time we don't have to distribute in because it's a 1 in front, which does nothing. Woohoo. Okay, so then we're going to get 15x plus 5 plus 9x squared minus 3x all over 3x minus 1, 3x plus 1. So we're basically doing addition and subtraction on both sides of it, correct? That's really all we're doing. And then equals 9x squared, these cancel, minus 1. Then what's my next step after I've done addition and subtraction and whatever? And now I have left side equals right side. What do I do? Get rid of the bottom, but first do MPVs. X cannot equal plus or minus 1/3. Okay, now we can just write our numerators. 15x plus 5 plus 9x squared minus 3x equals 9x squared minus 1. No quadratic formula needed. Life is good. Because these cancel when you subtract them off. Then we get 15x minus 3x is 12x plus 5 equals -1. Then what am I going to do? Solve. Minus 5. 12x equals -6. Divide by 12 is not a non-permissible value. So we check our value, it does not match. What happens if our value did match? Say it actually was x equals 1/3, let's pretend. What we would do is we would cross it out and say x can't equal 1/3, and then we'd say extraneous. Extraneous. However, this is not real. I just made that up. Like, that has nothing to do with this question. But if the answer had been that, it would be extraneous. And there will be some of those in your homework. Okay? Does that make sense? So, just like addition and subtraction, our first step is common denominators. We're basically doing addition and subtraction on one side and addition and subtraction on the other side. That's basically what we're doing. We're doing like addition and subtraction twice. Super awesome. Put them together. Equal sign in the middle. Denominators the same. Set numerators equal. Boom, boom, boom. Math. Answer. Drop the mic. All right.